In this section, we will go through a routing algorithm called distance vector algorithm, DV algorithm. The basic idea of DV. The algorithm is operated by having each router maintain a table that is a vector, giving the best known distance to each destination and which line to use to get it. DV algorithm is a dynamic and distributed. It is commonly used in small networks. RIP is a typical example of DV. Now, let's look at the working principle of DV. In DV, each router uses two vectors, di and si, to denote the distance from a node to all other nodes and next node, or called as next hop. The nodes exchange path information among neighbor routers, and then each node updates its routing table according to path information. Assume di and si are the two vectors. di1 is the distance or delay from node I to node 1. si1 is the next node along the best path from node I to node 1. N is the number of nodes in the network. After the exchange of vector, each node uses following principle to update its routing table. The distance can be updated as dij equals to minimum dix plus dxj. X belongs to the set of A, in which A is the collection of the neighbors of node I. Dij is the shortest distance from I to node. Dix is the shortest distance from I to X, and dxj is the shortest distance from X to J. Besides the updates of the shortest distance, the node also needs to update the next node, Sij, to X. We have example of how DV algorithm works here. Topology is following. Router C receives three routing delay vectors from router B, D, and E. These vectors are as displayed. Now, delay between router C and the router BDE is measured respectively, is 6, 3, and 5. Try to answer the routing vector of router C after update. The solution to this example is explained as follows. We take node A as the example. For node C, there are three neighbors, B, D, and E. From C to A via neighbor B, the distance is 11. Via D, the distance is 19. Via E, the distance is 12. As we are now looking for the shortest path, we pick up B as the next hop and update the distance as 11. We do the same calculation for the other nodes, and then we can easily update the distance vector and the next hop vector. In the end of this section, the question for you to think about is, what can be the disadvantages of DV algorithm? That's it for this section. Thank you.